Hello everyone, in this video we are going to discuss the principle of refrigerator and we will calculate the efficiency of refrigerator. In this diagram we draw a cyclic process, let's say from A to B and then B to C and then C to D in anti-clockwise direction, from A to B and then B to C, C to D and then D to A. Our initial and final position is A. It is a cyclic process. Let us consider these four processes. Two are isobaric and two are isochoric process. Let's consider first of all from A to B. A to B. As A to B is an isochoric process, and in this process the pressure is decreasing according to the ideal gas equation. PV is equal to nRT, and we can write the pressure is directly proportional to temperature as volume is constant. And if we decrease the pressure in this process, in isochoric process, temperature will be lower. From A to B it is a cooling effect, and if there exists a cooling effect, then it is a cooling effect, and due to the cooling effect some heat from the surrounding or high temperature reservoir can enter to the system. Let's say the Q1 heat enters to the system from in process from A to B. Now consider from B to A and then B to A. It is an isobaric process because the pressure remains constant and there is expansion. V1 to V2 the volume is increasing, and due to expansion there is also a cooling effect. Due to B to A is isobaric expansion, and due to expansion heating cooling effect expansion, there is also a cooling effect, and due to this cooling effect the temperature will decrease, and if the temperature decreases some heat can enter to the system. The Q2 heat is enter to the system. Now consider C to D. From C to D is also an isochoric process. The volume remains constant but pressure increases. If we increase the pressure according to the ideal gas equation, the temperature will also increase. It is a heating effect according to the ideal gas equation. PV is equal to nRT, and the pressure is directly proportional to temperature. As C to D, the pressure is increasing in this direction. The P1 is low pressure and P2 is a high pressure. The C to D, the pressure is increasing, and if the pressure is increases, the temperature will also increase, and it causes heating effect. And due to this heating effect, some heat can flow out of the system. The Q3 heat will flow out of the system in this isochoric process. Now consider from D to A. The D2A is an isobaric process, and the volume is decreasing because at D the volume is V2, but at point A the volume is V1, and we go in this direction. D to A, it is a compression, and due to the compression the temperature will increase. It causes the heating effect. It is an isobaric. D2A is isobaric compression, and due to compression there cause a heating effect, and due to this heating effect the temperature will increase. Some heat can leave out of the system, go out of the system. The Q4 heat is leaving out of the system, and it is our complete cyclic process. And the cycle is anti-clockwise, and due to this anti-clockwise the work done is, due to anti-clockwise direction the work done is negative, and due to this negative work done it means that we have to do work on the system. Negative work done means the work done on the system. To achieve this cycle we have to do work on the system, and if the cycle is clockwise then work is done by the system. Now we can draw the overview of this process as here. Here is a high temperature reservoir and here is a low temperature. For example, it is a low temperature reservoir, and low temperature reservoir there is a refrigerator here at working. Some heat is traveling from low temperature reservoir QL to the Q to the high temperature reservoir, and due to this, work is done on the system. The arrow of work is onto the refrigerator, means onto the system. From this equation, we can calculate, from this diagram we can calculate the efficiency of this refrigerator. The efficiency can be written as the efficiency is equal to the output divided by input. Here the output of this refrigerator will be the QL, which is desired. The heat leaves from the low temperature reservoir. As we know that the heat cannot flow out of the low temperature reservoir, but in this process, because the work done is negative and work is done on the system, the heat flows from low temperature reservoir to high temperature reservoir. Then efficiency is the output, and our output is QL, which is the heat travels from the low temperature reservoir, and output is QL, and our input is work done. According to the first law of thermodynamics, our work done will be equal to the delta Q, because it is a cyclic process. And according to the first law of thermodynamics, delta Q is equal to delta U plus work done, because the delta U is equal to 0 because of the cyclic process. The delta Q is equal to the work done. The work done is equal to delta Q. Here the delta Q is the difference between the QH and QL. We can write the QL over W, work done will be equal to the QH minus QL. It can be written as this: 1 divided by QH minus QL, and QL to the denominator, QH minus QL of the denominator. And if we cancel out the QL, write the separately QL with the QH and QL, the efficiency will be equal to 1 divided by 1 minus, sorry, QH by QL and minus 1. This is the efficiency of a refrigerator. Thank you for watching.